All right, so hope everybody still remembers our derivation of finite elements from last lecture. All right, so if not, let's review a little bit of what we did. Okay, so first of all, we have studied what is finite elements. So far, we have explained that finite elements is basically minimizing energy, right? So, for example, in the last lecture, we have been minimizing the energy, which is defined as an integral from 0 to 1, an unknown function, which is what we are minimizing among, minus a u0, the target, which we assume we already know, the square integrated over dx, right? So that's what we are trying to minimize yesterday. The reason we want to minimize an energy like this is because for many physical systems, the solution to a PDE or to actually even problems that are described beyond PDEs can be characterized by minimizing a certain type of mechanical energy. So we are looking into how do we solve this energy minimization problem under the constraint or the restriction that for U being a summation of AI and Phi. And what are the Phi's? What are the Phi's? Why are we representing our U as a linear combination of Phi's? What did you say? Yeah, so the Phi's are something called the basis of a linear space of functions in which we want to find our solution. And the last lecture, do you remember what kind of basis function did we use? We used the nodal basis functions, which looked like that. So if we have my phi and my x in between 0 and 1, in particular, we used we adopted three elements, right, equally spaced between 0 and a third, between a third and 2/3, and 2/3 and 1. So the first basis function goes down like from 1 to 0 and stays 0 afterwards. The second basis function, I use green, it goes from 0 up to 1 and then 1 back to 0 and stays 0 afterwards. Now the third basis function stays 0 here and goes up to 1 and goes back to 0 at 1, and we have a fourth basis function that stays 0 over here and goes up at 1 at the last grid point. Right, so basically we have these four different colors. Blue is phi0, green is phi1, gray is phi2, and finally red is phi3, right? So we have these basis functions to play with. And we know that with an arbitrary linear combination of these basis functions, we can reconstruct any kind of piecewise linear and continuous function we want. So solving this problem is basically within the space of piecewise linear and continuous functions, we want to find the function that is as close to U0 in that kind of energy metric as possible, right?